Let me just show you one rectangular solid. Here's an example of a rectangular solid. If you'll notice, still has 6 surfaces, just like the cube does, but all the surfaces don't end up being squares. You'll notice the top of this is a rectangle, also the bottom is a rectangle. The top and the bottom and the front and the back are rectangles. This particular rectangular solid just happens to have 2 surfaces that end up being squares. So for this particular one, 4 of the surfaces are rectangles and 2 are squares. And sometimes that happens in a rectangular solid. The main thing to remember is that all of your surfaces don't end up being squares. At least some of them end up being rectangles. So we're going to find the volume of a rectangular solid like this box. To replace our sidewalk, or to replace your sidewalk, you need to find how much concrete you would need. The sidewalk is 60 feet long, 2.5 feet wide, and we want the concrete to be 1/4 of a foot deep. What volume of concrete should you buy? Now, because we're going to assume that our sidewalk is rectangular shape, so we have the shape of a rectangle, but we want it to be 1/4 of a foot deep, that's going to give us our 3rd dimension. So it's really like we're finding the volume of a rectangular solid. So we're going to use our formula, length times width times height. So our length is going to be 60 feet, our width is going to be 2.5 feet, and our height will be the depth of the concrete. So let's fill those in. 60 times 2.5 times 1/4. And so now it's just a matter of multiplying. So let's make them all, fix them all so that they look like they should to multiply. We put 60 over 1 times, make this improper, will be 5/2 times 1/4. Then we look to see if we can do any reducing. 2 we're going to do 1 time, 2 we're going to 60 30 times. So when we multiply straight across, we'll end up with 1. Well, actually, I see something else I can reduce before I multiply. I've still got this 4 left here and the 30, and I can divide 2 into both of those. So let's do that. 2 will go into 4 2 times, and 2 will go into this 30 15 times. So now if we multiply across, we'll have 15 times 5 times 1, which will give us 75. And then 1 times 1 times 2 will be 2. So we'll end up with 75/2, which will divide out to be 37.5. If we divide 2 into 35, we'll find that it goes 37 times with 1 left over. Now we're finding the volume of concrete. Anytime we're finding volume, we're working with cubic units. Our unit was foot, so it's going to be 37.5 cubic feet. Or we could just leave it 75/2 cubic feet. Now when you write your cubic feet, you can put it like this, or you can put your feet and put your little 3 up here. That's another way of writing the cubic feet. So remember, with volume, you're going to use cubic units. On the area problems, like the triangle and the trapezoid, you use square units. Let's do some practice problems with volume. Number 1, use V equals LWH to find the volume of a freezer that is 3 feet long, 2 feet wide, and 5 1/3 feet tall. Number 2, use V equals to S cubed to find the volume of a cube with an edge S equals to 2/3 of a yard. After you copy the problems down, stop the tape to work on. The practice problem answers: number 1, 32 cubic feet. Number 2, 8/27 cubic yards. This concludes Tape 15 and our work with finding the area of triangles and trapezoids and finding the volume of cubes and rectangular solids.